So now it comes time to conduct the experiment. What you need to do first is, once all of the materials have been laid in front of you and the terminals, crocodile clips and a light connector has been affixed to the tray, first you need to get the negative push connectors, connect them to their correct terminals, the positive push connectors, connect them to their correct terminals, and then the light globe. So connect the light globe to its connection. And the next step is to connect the power supply. So when I connect this in, it should simulate a complete circuit, because once the power goes into the terminal, electricity will travel through the positive wire into the positive terminal, out from the positive terminal, through to the other side of the positive terminal, underneath, positive wire, into the wire connection, in which the blue is the light. So it goes through to the light source, back out to another connection, through to the negative, and again negative push connectors, and back to the power supply terminal. So that is a complete circuit which goes all the way around. So let's put it to the test. Turn it on at the light source. So now we're going to try to connect the power supply into the terminal and watch the circuit work. Let's give it a try. And there you have it. The light has turned on because the circuit is complete. So what if we try to simulate a broken circuit? That would mean that we need to interrupt the circuit so it cannot be complete. For example, take out one of the positive wires and it stops the circuit. Plug it back in, complete again. Take out a negative circuit and it stops. Plug it back in and it's complete. First, for my experiment, I'm going to test aluminium foil and whether it has an effect on the light globe. So, I'm going to connect the connection. Now this is the full circuit connection because both connectors are still connected. Now, if I disconnect one of these connectors, the connection will then run through down the resistor to the light globe and back around to be complete. So that is why we have a dimming effect if this experiment works. Let's give it a try. So as you can see from disconnecting the connector, there was not really a noticeable difference in the dimming of the light globe. This means that the aluminium foil is too conductive and it has not got enough resistance to show a noticeable difference. So for our next test in our experiment, we're going to test an eraser for its resistance. So let's first connect a complete circuit. And now let's make the current go through the resistor to see if the rubber will have an effect on the dimming. So from this experiment, you can see that the rubber has completely put out the light bulb. That means that all of the energy has been through the power supply and is being used in the resistor. And it is not conductive enough for any charge to get through to the light globe, meaning that it is essentially a broken circuit. So this tells us that rubber is a very good insulator. with too much resistance for our 12-volt power supply. Our next test in the experiment is to test a pencil and whether this has an effect on the resistance of the light globe. So let's connect the complete circuit. Now let's remove the push connector to make the charge go through the resistor and see whether it has an effect. Okay, so similar to the rubber, there is no charge currently getting through to the light bulb. This indicates that the pencil has too much resistance for the 12-volt battery and all of the energy is being used. I thought about what kind of materials I could use that would be a good conductor. So I was thinking about metals. And inside of a pencil there is lead. So I thought by stripping away the wood, which is an insulator, I might be able to simulate the dimmer by making the current travel through the shortest path, which is directly through the lead, over to the light globe. Let's test. So I've connected the crocodile clips to the exposed lead. That means that the current will travel into the resistor and will travel across the easiest or shortest path possible to the other side of the crocodile clip, and hopefully we'll be able to complete the circuit. Okay, so now let's take away the connector so that the current will travel through the pencil. And as you can see, that was a noticeably dimmer difference in the light globe. This means that the lead is a good resistor and it is not taking up too much energy so that it turns the light globe off. It is just conductive enough so that charge can still travel through and dim the light. It is important to also note that the lead is currently getting very hot, so it is important to not keep the lead on the electricity for too long. To simulate the dimmer, I will now travel the crocodile clips closer to each other to reduce the resistance. Hopefully this will increase the light output because the charge has less room to travel across.